Hello, my name is Sean Phillips. The following presentation is a demonstration of software tools that have been specifically developed to support space-based mission operations and analysis. What you'll be seeing is a demonstration of these tools and specifically how JavaFX 8 has enhanced the ability of the user to do their daily workflows. I'm a senior software engineer with a company named AI Solutions. I'm the lead developer for all these tools you're about to see. You can find me on Twitter, Tumblr, and at the D-Zone. AI Solutions is a NASA and U.S. Air Force corporate partner who specializes in all manner of space-based mission design, analysis, and operations. This tool that you see was demonstrated at the 2013 Java 1 Community Keynote Address. This is used on the NASA mission MMS, Magnetospheric Multiscale. The power of this application is that it can take files that are generated, data products, day to day, and they can be used to lightly and very quickly explore using drag and drop features in JavaFX. So for instance, I can drag positional data and get a view of the mathematical coordinate frame of a daily orbit. I can look at the velocity data in the same manner. This uses JavaFX drag board and drag and drop event support. I'm also using a range slider. This range slider was taken from the great open source third-party ControlsFX library. This constrains my data set to, in this case, a specific day in the life. So now when I drag the same information onto the charts, it's clearly constrained by the range slider. Then I can use JavaFX binding and a combination of the NetBeans platform lookup, by which this entire application is based on, to send that information over to Whirlwind, which is an open source 3D toolkit that many of you have already seen. And as you can see, the entire orbit is represented and the constrained area is then highlighted in the orbital flow. The next application you're seeing is a tool that was developed for the James Webb Space Telescope. This is to do contact analysis. Again, this is based on the same Polaris plugin platform, which is itself based on the NetBeans platform. What you're seeing is a JavaFX panel which is scanning through the entire project looking for all the contact reports that exist, combining them, and then generating a final visualization which will tell the user all the contacts in time ordered. There's over 150,000 data points that are being loaded in. This takes advantage of parallel streams in JavaFX. It takes advantage of the scatter plot capabilities in JavaFX. And what you're about to see when it finishes rendering the chart on screen is a custom data node for each contact that's achieved between the ground station and the spacecraft. I'm taking advantage of the hover events. I'm adding custom hover, as you can see. And I even added custom zoom capabilities, which allows me to zoom in deeply into the data to a finer grain. And as you can see, the Gantt-like view that was up there before is starting to separate, and we're getting more granularity. I can even add clicking events, which allows me to click, and it'll take me straight to the file in question, in fact, straight to the line where that data is located. Again, this is a combination of JavaFX binding and the NetBeans platform lookup. The final application I'd like you to see is for a mission called OSIRIS-REx. This is an asteroid sample and return mission that's scheduled for 2015 or possibly 2016. The intent of this mission is to actually take a spacecraft, go out to the asteroid, actually come in close proximity enough to sample, and then return to the Earth. One of the difficulties is to be able to see the gravity and the positional information in 3 dimensions of the asteroid. So we're using JavaFX 3D to show the actual asteroid dimensions. What you see right now is a cube, and it is all JavaFX 3D, This is based on an upcoming 3D JavaFX 3D third-party library called FXYZ that allows you to load any manner of data into a data visualization container such as this. I'm allowed to now go and I can browse for my asteroid file, which in this case is just simply a vertex file that's been collected from another asteroid mission. In this case, this is the Itagawa asteroid loaded from the Hayabusa mission. And now I can see the actual asteroid as a triangle mesh. I can zoom in and get a closer look, and as you can see, the triangles start to manifest themselves. And this is important because we can, once we have something in 3D, we can then do other things in JavaFX 3D, like create geodesic histogram overlays, fixed grid overlays, surface plots to represent gravity and density. Here are some links to the missions that I just brought up. There's also a link to my company. If you enjoy space or are interested in that field and you would like to apply, feel free to contact myself or contact our company. Send your resume. And if you're interested in some of the information that I described from the JavaFX point of view, here's some interesting links, including the 3D tutorial, ControlsFX, again, a great third-party library, and an early preview of FXYZ as